Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 10 of a unit work, power and energy. So let's begin with today's class. This is the second lecture of a collision. In the first lecture we were discussing with the elastic collision, and if you remember that we have derived this relation for that when object is having mass m1 and it is moving with velocity u1, another object having mass m2 moving with initial velocity u2, they are going to collide somewhere, and their after velocities, that means the velocities after collision, would be equals to v1 and v2. Then we can have the relation as v1 is equals to m1 minus m2 divided by m1 plus m2 into u1 plus 2m2 divided by m1 plus m2 into u2, and v2, it's a velocity, or we should say velocity after collision of the second object, would be equals to m2 minus m1 divided by m1 plus m2 into u2 plus 2m1 upon m1 plus m2 into u1. This is what we have derived last time. Even one more very important term, that is the coefficient of restitution E, that has been explained and that has been derived. It was the relative velocity of separation divided by relative velocity of approach. So according to this E could be written as v2 minus v1 divided by u1 minus u2 if it is the case of elastic collision. If it is the case of elastic collision, then E would be equals to 1, and for inelastic collision, if it is the case of inelastic collision, this E could be from 0 to 1. Yes, so please do remember this thing. Please do remember this thing. And now we are going to switch to the special cases of elastic collision. So let's have a look. These are the special cases of elastic collision. Let's discuss the case one. We can say that if two bodies have equal masses, then we can have it's an m1 equals to m2 is equals to m. We have this relation that we have derived it. It's a v1 is equals to m1 minus m2 upon m1 plus m2 into u1 plus 2m2 divided by m1 plus m2 into u2. If I replace the relation with this, it's a both are having same masses, then this m1 minus m2, which is m minus m, which would be a 0, so this would be a 0, plus this is equals to 2m divided by m plus m, again 2m, so this is 2m, this is 2m, so only the term that I have been left with, it's a u2. So the final velocity of first object should be equals to u2, that is the initial velocity of the second object. Now let's check for the second object. Let's check it. So when I say it's a for a check-in, when I say it's a for second object, what I can have is it's a v2 is equals to 2m2 u2 plus m1 minus of m2 into u1. This was the relation for the second object. So this is v2, that would be equals to 2m2 into bracket, sorry, I made a mistake. It's a v2 is equals to 2m1. Yes, the relation was correct, I made a mistake. Yes, so this v2 is equals to 2m1 upon m1 plus m2 into u1 plus m2 minus m1 upon m1 plus m2 into u2. So, and we were discussing that if both the objects are having same mass, that is the m1 is equals to m2 is equals to m, then I can have this is 2m, even this is 2m, so I have been left with the u1, and now on here it's a m minus m, which would be a 0, so this would be the 0. So this is the case when v2 is equals to u1. So if you observe it carefully, that I have received that v1 is equals to u2, and now v2 is equals to u1. So we can say that in the case of an head-on elastic collisions of two bodies of equal masses, please keep this in mind, that this is for the equal masses only. The bodies simply exchange their velocities after collision. That means the final velocity of second object is the initial velocity of first object, and final velocity of first object is the initial velocity of second object. I hope this is clear. So this, in this case, v2 is equals to u1, v2 is equals to u1, and v1 is equals to u2. Is it clear? Is it any doubts in this? Is there anything? Is there anything? Anything? Are you sure? Are you sure? Do you understand this completely? So let's have a look that we are going to do this with certain examples. Let's do it. That let's suppose this is an object of 4 kg which is moving with 20 meter per second in this direction. Another object having same mass, it's a 4 kg, and this is moving with a speed of 10 meter per second in this direction. Let's suppose they are going to collide somewhere, and this is second object, this is first object, this would be the second object, this would be the first object. This is the final velocity v1, this is the final velocity v2. We have been asked that for elastic collision, for elastic collision, find v1 and v2. That for elastic collision, find v1 and v2. This is what required. So let's find out the v1. The v1 was this are the same 4 kg 4 kg. So this is equals to m1 minus m2 divided by m1 plus m2 into u1 plus 2m1 divided by m1 plus m2. It's a 2m2 into u2. So if I replace the value, this could be m1 minus m2, this is 0, plus 2 into m2, it's a 4 kg, divide by 4 plus 4, 8 kg, multiplied by velocity, this is 10. So this has gone, and this v1 become a 10 meter per second. I hope this is clear. Is it clear? Is it? Great. Let's find out the v2. The v2 was, it's an m2 minus of m1 divide by m1 plus m2 into u2 plus 2m1 divide by m1 plus m2 into u1. So this would be equals to, this is 4 minus 4 divide by 8 into u2 plus 2 into 4 divide by m1 plus m2, and this m1 plus m2 could be written as, it's 8 multiplied by 20. So this has been 0, yes, and this 2 4 side plus 20. So this is the case that v1 was 10 meter per second and v2 is equals to 20 meter per second. I hope this is clear. Is it clear? So what the situation was, that initially first object is having a 20 meter per second speed, second object is having 10 meter per second speed. So when they collide and when they are having an equal mass, their velocities after collision is that first body is having a speed of 10 meter per second and second body is having a speed of 20 meter per second. Yes, so this is the case that after collision they are going to exchange their values. That is, the value of first object is the value of the initial velocity of the second object and vice versa of this. Is it clear? Yes, this is very very important concept, and this is required when we go for the very good conceptual questions. So please keep this in your mind. Please keep this in your mind, and do remember this. We are going to use it in future also. Let's look at the case 2. It says that before collision, if first body is moving with u1, it is the first object that is moving with u1, and the second body is at rest, it is at rest, then after the collision this v1 equals to 0 and this v2 is equals to u1. But for this what I need to have is it's an m1 that should be is equals to m2 that should be equals to m. For this to happen, for this is to happen, if m1 equals to m2 is equals to m, then after collision the first body will come to rest and the second body will start moving with the velocity that first body is having. That means again this is the same kind of exchange of velocity only. This is the case when we say that this is the exchange of velocity only, but this is possible if their masses are equal. So please keep this in mind. Let's have a look that how does it behaves. This is the case when v1 this is equals to m1 minus m2 into u1 plus 2m1 into bracket m1 plus m2 into u2. As I know that u2 this is initially at rest, so this has become to the 0. So v1 will be m1 minus m2 upon m1 plus m2 into u1, and v2 v2 could be written as 2m1 upon m1 plus m2 into u1 plus m2 minus m1 upon m1 plus m2 into u2. This is the standard relation, and as I know that this second object was initially at rest, so this would be come to a 0 and this v2 is equals to 2m1 upon m1 plus m2 into u1. And from this we can have this relation that v2 is equals to 2m1 upon m1 plus m2 into u1. Now as we have discussed, if m1 equals to m2 is equals to m, then what we can have is m1 equals to m2 is equals to m. Then v1, let's have a look that v1 is equals to m1 minus m2 upon m1 plus m2 into u1, and this was the v2, this is equals to 2m1 upon m1 plus m2 into u1. So let's put up the value. The final velocity of first object would be the 0. Yes, v1 equals to 0, and the final velocity of the second object would be equals to u1. I hope this is clear. So indirectly it is the same thing that if m1 equals to m2 is equals to m, and second body is at rest initially. When I say initial, I mean before collision. Yes, then after collision first body will come to rest and second body starts moving with initial velocity of first body. Yes, please keep this in mind, this will help us. So are you ready to have one of the question based on this approach? Yes, let's say this is 4 kg object which is moving with 20 meter per second, moving in this direction. This is again 4 kg object which is at rest. They are going to collide somewhere, and what I want, let's say this is first, this is second, and this is first. This is v1, this is v2. So as we have discussed that this is for elastic collision, the question says that for elastic collision find v1 and v2. This is what we require. We need to find out a v1 and v2. So we can have it's a v1 is equals to, this is m1 minus m2 upon m1 plus m2 into u1 plus 2m2 divided by m1 plus m2 into u2. So let's just put the value. It's an m1 minus m2, this 4 minus 4, this 4 minus 4, it is equals to 0, plus 2 into m2, it's a 2 into 4, divide by 4 plus 4, it's an 8, into u2, into u2, this is initially at rest, so this would be 0, so this would be the 0 meter per second. I hope this is clear. Now let's work for the v2. So v2 relation was, it's an m2 minus of m1 divided by m1 plus m2 multiplied by u2 plus 2m1 divided by m1 plus m2 multiplied by u1. This will be, this m2 minus m1, it's a 0, plus 2m1, it's a 2 into 4, divided by 4 plus 4, 8, multiplied by u1, that is of 20. So this has gone and this has will be 20 meter per second. So according to this, initially this was at rest. I'm talking about the second object. I'm talking about the second object, that initially this was at rest, and this is now after collision starts moving with a speed of 20 meter per second, and this will be at rest. Yes, even this is the case. If you have played the billiards, you might feel that a striker would be there. It will strike to the coin, it will strike to the coin, and the striker can come to rest in certain situations, but and coin starts moving with the same speed. Same thing is true, correct for the carom board as well. So this could be the cases, this could be the various cases where this situation will occur. Is it clear? Is it any doubts, any issue up till now? Is there anything? Are you sure? Are you? Great. Now let's move to the next case, and this is very interesting case. In fact, it says that when a smaller body collides with a heavier body, it's an, let's suppose it's a case when m2 is much greater than m1, and let's assume that the heavier body was initially at rest, that at u2 is equals to 0. So this is the case that smaller body collides with the heavier body, and the heavier body was initially at rest. Let's see what will happen. That this is the case before collision. Before collision, this is the m1, and it is moving towards the first, it is moving towards the second body with a velocity of u1. Second body was initially at rest, and after collision this will happen, that this is again going to be at rest, but this is moving with the same velocity but in negative direction. This is the same case if you observe this, that let's suppose this is the wall. For me it's a second object, this is the first object, it's a u1. Let's suppose this is a ball having mass m1. If it is moving in this direction, then after collision it is going to be move in the same direction with speed u1. It is rebounding with same speed. Yes, but only the direction has been changed. So this is what they are explaining. I hope this is clear. So let's understood this, with the help of equation. So here in this case, as I understand that my mass m2 was much greater than m1. As it is much greater than m1, we can neglect the mass m1. Once we are going to neglect it, what happens? Let's see that this is v1 is equals to m1 minus m2 divided by m1 plus m2. Here you are not going to observe the m1. Yes, so it's just the minus of m2 divided by m2 into u1 plus 2 into m2 divided by m1 plus m2. Here you are going to observe that this is u2. My second object was initially at rest. So as it was at rest, this u2 would be 0. So this total number would be 0, because u2 is equals to 0. So this is equals to v1 is equals to minus of m2 by m2 into u1, and thus it's a v1 is equals to minus of u1, and v2 final velocity would be zero, as it is the obvious, that any ball when any ball strikes the wall is not going to move anywhere. Yes, so even after the collision, it would be at the same place. Is it clear? Is it is it clear? Let's just see the next case as well. It is the same. It is the same application, and then we will do a questions based on this at the same time. It says that when a heavy body which is m1 is much greater than m2 collides with a much lighter body at rest. Now lighter body is at rest. It is the exactly the reverse situation. It is exactly the reverse situation when that much heavier body is going to collide the much lighter body, and the lighter body is initially at rest. That is, it is at u2 equals to 0. So now here we can neglect the mass m2. Here we can neglect the mass m2, and when we can neglect the mass, when we are going to neglect the mass m2, the situation would be before collision. The mass m1 is moving. Mass m1 is moving with a speed of u1, and second object, it's an m2. Second object m2, which was initially at rest, this is u2 equals to 0. So this was the situation before collision. Now after collision, the situation would be the v1 is equals to u1. That means the heavier body keeps moving with the same speed, but this lighter body having a twice of the velocity of the initial velocity of one of the first body. Let's try to prove this with mathematical calculations. It says that v1 is equals to m1 minus m2 upon m1 plus m2 into u1 plus 2m2 upon m1 plus m2 into u2, and according to the relations it is m1 much greater than m2. I hope this is clear. So when it is the situation, I'm just going to neglect the m2. Yes, m2 is approximately 0. So this is m1 minus m2, m1 plus m2. This m2s have no significance, so I write it. It's a v1 is equals to m1 divided by m1 into u1 plus as I said that u2 was initially at rest. Yes, the lighter body was initially at rest, so this is going to be 0. This is u2 is equals to 0. So this is the case when v1 is equals to u1. This is the case when v1 is equals to u1, and this is the second case. It's a v2. So this v2 is equals to 2m1 upon m1 plus m2 into u1 plus m2 minus m1 upon m1 plus m2 into u2. As initially this was at rest, so this would be over. This is at 0, and v2 this v2 could be written as 2m1 upon m1 plus m2 into u1. So this could be arranged such that if m2 is approximately equals to 0, that can be neglected. It's a 2m1 by m1, and this has gone, and this is 2 into u1 that I have been left with. So this is the mathematical derivation of the same situation. Yes, so let's have a numerical aspect of this, and let's just try to prove it that does it really work or not. So let's have a look. What we are supposed to do is that this is the wall having mass of, let's say, 100 kg. This is a ball having mass of 1 kg. Even it is very heavier, but still we can work. Yes, it's 30 meter per second. It is at rest initially. Yes, so the question is for elastic collision. Find out final velocities of ball and wall. Got it? So Now we know the formulas and everything. Now try to do this. Let's try to do this using the help of conceptual approach. What was it? That it says that for elastic collision, it is the elastic collision. So what we can have is it's then m1 u1 plus m2 u2. That should be is equals to m1 v1 plus m2 v2. So initially this is of 30 meter per second, this is of 1 kg. So this is 30 into 1 plus m2. It is of 100 kg but it is initially at rest, so we can make it as a 0 equals to m1 into v1. This is equals to 30, sorry, it's a 1 into v1. So this is equals to 1 into v1 plus m2 into v2. It's an 100 into v2. I hope this is clear. Is it clear? Is it? Great. Now let's have one more relation. It's a E is equals to, this is relation number 1. E is equals to velocity of separation. It's a velocity of separation divided by velocity of approach. So the thing will be E is equals to velocity of separation. It's a v2 minus of v1 divide by u1. This was the 30 because it is initially at rest. So this is 30 is equals to v2 minus of v1. This would be my second relation, and my first relation was something like this. That let's write it down and try to solve this. The first relation was 30 is equals to v1 plus 100 into v2, and the second relation, this was first relation, yes, the second relation was 30 is equals to minus of v1 plus v2. This was the second relation. Now as I could understood that, as I understand that, when I understood that this is the second object, when what I'm talking about, it's a 100 kg of the object. So the thing will be I can ignore the effect. I can ignore the effect of this, and that's why this is not going to help me to directly solve this. But what I assume is that as wall is having wall is having much higher mass as compared to ball. So so wall is not going to move. Wall is not going to move anywhere, and ball will rebound. Ball will rebound with same velocity. I hope this is clear. Yes. So what we understood is v1 should be equals to minus of 30, which can be seen over here. v1 could be equals to minus of 30, and if we put v2 is equals to 0. So this is v1 that would be equals to minus of 30, and v2 would be equals to 0. I hope this is clear. Is it clear? Is it is it clear? So do you understand this? This is the second approach. If you wish that no sir, I am comfortable with the first one, you can always go with it. You can always go with it. But even this could be the approach to get it done. Yes, with whatever approach you are comfortable with, you must carry forward. Is it clear? Is it? Are you sure? Are you sure? Great. So now let's just move to the next question. Let's suppose the situation is that This is an object. Let's say this is a truck having mass of m2 and it is moving with velocity u2. Certain object m1 is there. Let's suppose it is a ball and it is even moving in this direction. This is the ball. If this are going to collide, something like this, that this was truck and ball has hit to the truck, then let's assume that what should be the final velocity of the truck and the ball. This is truck, this is ball, this is v2, this is v1. So they have said that for elastic collision, find out v2 and v1. This is required. So what we understood is that we have derived two relations, but in that any one of the object was at rest, that either the heavier object would be at rest or the lighter object would be at rest. But here both the objects are moving. So what I can do is that let's suppose that this is the my v1 should be equals to, as I understood that this is truck, this is ball, so there is no need to say it, but that is to be understood that m2 must be much greater than m1. And when m2 is much greater than m1, that means you can ignore the effect of the mass of the first object. So let's carry on. It's a v1 that should be equals to m1 minus m2 divided by m1 plus m2 multiplied by u1 plus 2m2 divided by m1 plus m2 into u2. So now let's just try to do as per our requirement. We understood that m2 is much greater than m1. That means if I ignore the effect of this m1, this would be v1 should be equals to minus of u1 plus v1 would be equals to minus of u1 plus 2 into m2 divide by m1 plus m2. It's an m2 only because we are going to ignore it, m1 multiplied by u2. So if I cancel this, it would be, I am having the relation, it's a minus of u1 plus 2 into u2. So v1 is equals to minus of u1 plus 2 u2. This is the speed of the ball. It's a v1. Now let's just find it out. That what should be the speed of the truck after the collision. So the master relation of v2, it's an m2 minus m1 divided by m1 plus m2 into u2 plus 2m1 divided by m1 plus m2 multiplied by u1. And we know that it's an m2 which is much greater than m1. So v2 could be written as, this could be ignored, so this is only the m2 by m2 into u2 plus here m1 is going to be ignored, so this is 0 because m1 is much smaller than m2. Yes, so no need to multiply or divide it. So this is v2 is approximately equals to u2. That means it is going to move with the same speed. I hope this is clear. This is clear, is it? So v2, a second object, it was our wall. Oh, sorry, it was our truck. Sorry, my mistake. It's a v2 would be approximately equals to u2. This v2 would be approximately equals to u2, and this v1 object, it will be having a velocity of minus of u1 plus 2 u2. I hope this is clear. So if it was the situation that let's just try to feel it, that a truck was going with a speed of, let's say, 72 kilometer per hour. That means it is the 20 meter per second, and ball is there. Ball is there which have been thrown towards the truck with a speed of 50 meter per second. So they are going to collide for sure. And once they are going to colliding, suppose something like this. After that, a ball will be having a velocity of, let's assume it as a v1. That should be is equals to, v1 should be equals to minus of u1 plus 2u2. When I put up the value, I could have that v1 is equals to minus of u1, it's a minus of 20 plus 2 into 50. So it's 100 minus 20, that is equals to plus 80 meter per second. While I say plus 80, it is even moving in this direction. And let's work for the v2, the situation, what the velocity of that truck, it's a v2, that should be is equals to u2. While I say v2 is equals to u2, I must understand, that this is the velocity of truck, this is the same, which is 20 meter per second. So truck will continue to move with the same speed, but this ball will be having a higher velocity. I hope this is clear. Is it clear? Is it? Is it? So will you be able to solve this kind of questions? Will you be? Are you sure? Are you? Great. Now we have one more questions based on this. Let's see this. Let's suppose this is what we can say. This is one of the wooden block. It's a wooden log, or I should say, let's say wooden block. This is moving in vertically upward direction. This is moving in vertically upward direction with a speed of, let's say, 20 meter per second. It's a constant speed. Ignore effect of gravity at this time. So it would be the constant. It's a 20 meter per second. And one of the ball is there, which is moving in the downward direction, with a speed of, let's say that it is moving in the downward direction with a speed of 5 meter per second in the downward direction. So the question is that if they are having elastic collision, find out find out their velocities, find out their velocities find out their velocities after collision. So what would be the situation? In first situation, when both the objects v1 and v2 both are moving with the same velocity in the same direction, both were moving in the same velocity with the same direction, the master relation is, let's have a look, it's a v1 is equals to minus of u1 plus 2u2. This was the case when both the objects are moving in same direction. Yes. So now I need to change this. It's a v1 for my situation. That should be is equals to mu minus of u1 minus of 2u2. I hope this is clear. At this location, I hope you understand this. Do you? Do you understand this? That this v1 should be equals to minus of u1 minus of 2u2. So this is equals to minus of u1, which is a minus of 5, minus of 2 into 20, it's a minus of 40. So this would be a minus of 45 meter per second. Why 45? Sorry, why minus? Because after collision with this, it is going to move in the upward direction, and initially it is going in the downward direction, which I take as a positive, so now this should be considered as a negative. So this is minus of 45 meter per second. What about the wooden block? What about the wooden block? Yes, it will moving, or it will continue moving in the same direction with the same speed. It would be at 20 meter per second. Its speed will be same. It would be the 20 meter per second. I hope this is clear. Is it clear? Is it any doubts, any issues with this? Is there anything? Are you sure? Are you? Great. So let's just wind it up the session over here. This is this was the collision part 2. Yes, I have divided the total collision in smaller segments because this is the concept which requires in not only in 11th, in 12th too. So what I want is that you must clear the all the concepts, and that's why I have divided this into a smaller segments. So please do it. Please revise each and every segment very carefully, because this will help us to understand the collision in a very better way. I hope this is clear. Is it? Thank you. Have a good day. Take care. Bye bye.